In this video, we're going to use a research code written in Mathematica to make and view bare earth hillshade maps. This code makes the hillshade maps from high-resolution digital elevation data that was obtained from opentopography.org. I'm counting on you to use the pause button and navigation slider on your video app when you want to read or review the contents of this video. Before using the code, you're going to need a few things. First, you'll need a digital elevation model, or DEM, of the map area. That's a text file with 6 header lines before the matrix of elevation data. You'll need the geographic coordinates, decimal latitude and longitude of the center of the DEM that will be analyzed. You'll need the central meridian of the UTM zone in which the map area is located. And you'll need the azimuth and elevation of the illumination you've chosen for the hillshade map. For lineament analysis, this is approximately perpendicular to the linear features you plan to observe at a low sun angle. In this video, we will work with a DEM showing a 4 kilometer by 4 kilometer area around Stampede Dam in California. The DEM was developed from LiDAR data and has a 1 meter resolution. Here's the Mathematica code as you would find it after you download it onto your computer. It has a lot of comment codes in it. The instructions for how to do the next step are all here in yellow. The input data are in these little gray cells. And so the first thing we're going to do is we're going to import the digital elevation model. Now, after you have downloaded this code onto your computer, what you're going to want to do is find the square brackets on this input line and go from quotation mark to quotation mark and delete that entire bit of data. And now we're going to go searching for the appropriate data file on your computer. So we come up here to the Insert tab in the Mathematica header and come down to File Path. Now we're going to look around on your computer to try and find the data. And on my computer, the data is in a file folder called Stampede Dam blah blah blah. Inside that folder is another folder, of course, and the data I'm looking for is called output _be.dat. So the digital elevation model data is going to be in a file whose extension will be .dat. It's actually a text file, but the code would like to have the extension .dat to work from. So we choose that, and you'll notice that the file path is inserted between the square brackets, and we're ready to roll. The next thing we need to have is the center point of our map area in latitude. North latitudes are positive, and in longitude, west longitudes are negative. These are input as decimal latitudes and longitudes. We need to know the central meridian of our UTM grid, and in our particular case it is minus 123 degrees, so we just type in minus 123. Then we choose the azimuth of the illumination of our DEM, of our hillshade map I should say, and in this case I've chosen 130 degrees, and the sun elevation is going to be a relatively low 20 degrees. So this 130 degrees is clockwise from north, and so that's the direction that the sun is shining from. And the elevation angle is relative to horizontal, so this is just 20 degrees above the horizontal plane. Notice it says other relevant input tasks. This is just a little reminder. At the end of the code are the lines that instruct the computer where to put the results. And so we're going to export 3 files here. One is going to be a little JPEG image of the Hillshade map from one azimuth of illumination, and the next one is a second JPEG map. These are low resolution JPEGs. And then finally, there is a file with metadata that is created in Excel, so we can see all of the input and output data. Okay, so what we're going to do now, since we have all of the input there and have all of our export files ready to go, we're going to come up here and evaluate the notebook. Now this is going to take about a minute and a half, minute and 3/4. So I'm going to pause the video and we'll come back as soon as the results have come in. So we evaluate the notebook. You can tell by the bold brackets over here the parts of the code that have not been evaluated yet, or the evaluation has not been completed yet. So right now it is pulling in the input data, which is a really large data file, and it will eventually work its way all the way down through the code and make our maps. Okay, so we'll come back as soon as those maps are made. Okay, all of the computation steps have cleared and we now have some output. So those are the Hillshade maps created from the digital elevation model. One is shown with an illumination from about 130 degrees, so from this direction. And the other one is shown with the illumination 180 degrees away from that. So we're seeing both illumination angles here. This is the metadata, and we're not going to belabor that, but it is preserved in an Excel file that we can look at afterwards. I want to show you a few things about these little Hillshade maps, and they look pretty small at the moment, but you can click on them and these little anchor points pop up. You can grab a hold of those anchor points and make the map bigger. And you can just keep making it bigger and bigger until you fill up the entire window, and in fact it will even expand beyond the size of the window. Now as we're expanding it, you can see down here in the lower left corner, it's sort of telling you the size of that thing in pixels. And so now we've got 1418 pixels, 1420 pixels. So it's getting bigger and bigger. Now this particular image is of a DEM that has a 1 meter resolution. It is 4,000 meters on a side. And so I can keep expanding the size of this until these numbers here in the lower left corner are about 4,000 by 4,000. And at that point, each one of the pixels on my screen are going to be 1 meter across in the field. So I'll be able to blow this up as much as I want. And you can see that there's a lot of detail in this. Here's Stampede Dam. It's an earth-fill dam. You can see roads. You can see drainages. You can actually see individual bushes, okay? And lots of little pioneer roads and utility roads. You can really see a lot of detail in this. You can even see the strand lines along Stampede Reservoir. This sort of blah gray area over here is Stampede Reservoir. So what if I want to save this map at a higher resolution than is just naturally produced as we run this code? Well, once I expand it using the little anchors to the point where I want it to be preserved, what I do is I click on it to make sure that it's selected. I come up to File, and I can save selection as, so I'm going to save the map as, and then I just choose a name for it. And it's saved as a PNG file here, but I can save it in whatever format I want, JPEG, TIFF, and PDF, and so forth. Today we're just going to save it as a PNG file. I can save it on my desktop, and now I'm going to have a nice, big, higher resolution Hillshade map that I can plop into Adobe Illustrator or some other program and look at the map. I can annotate the map and so forth. So that's the gist of it. Let me know if you have any questions in using this code, and I'd be happy to address whatever problems you have and get you over the learning curve. Thanks a lot. Bye.